Hello and welcome to another video on solving simultaneous equations, and in this video we're going to get some more practice using the substitution method. Now I know that this method isn't taught very much in schools, and I know that whenever a student who I've been teaching has been asked to solve simultaneous equations, they go straight to the elimination method without thinking about what equations they're solving. So sometimes the elimination method does work better, but sometimes the substitution method is a lot more efficient in order to solve simultaneous equations. So I've got 4 pairs of simultaneous equations here. So as always, if you want to have a go at doing this first, I encourage you to pause the video and see if you can solve these equations. Okay, so let's go through these now. So the first one, we've got y equals 3x and 2x plus y equals 5. So what we're going to do is we're going to substitute this top equation into our second equation. So notice how we've got y here. Now instead of writing y, I can write 3x. And the reason I can do that is because y is equal to 3x. So this top equation is basically saying that y is exactly the same as 3x. Y equals 3x. So wherever I see a y, I can just replace that with 3x. So let's rewrite this second equation, and instead of writing y, I'm going to write 3x. So we've got 2x plus 3x. So I've just replaced y with 3x, and that equals 5. And then I can simplify this. 2x plus 3x is 5x. So 5x equals 5, therefore x equals 1. Okay, so I've got my value for x. Now I can just substitute this value for x into my first equation to get the corresponding value for y. So y is going to be 3 times x, which is just 3 times 1. Therefore y equals 3. So I have my values for x and y. When x equals 1, y equals 3. Okay, let's look at question 2 now. So here we're told that y equals 2x minus 1. So again, in my second equation, wherever I see a y, I can just replace that with 2x minus 1 because y equals 2x minus 1. So if I rewrite my second equation, we've got 3x plus 5 times y. Well, y is 2x minus 1. So we've got 2x, sorry, not 2y, 2x minus 1. And that equals 34. So again, just to recap, what I've done is I've just replaced y with 2x minus 1. Now let's expand the brackets. So here we're going to have 3x, and then 5 times 2x is positive 10x, and 5 times negative 1 is negative 5, and that equals 34. So if we just simplify things a bit, 3x plus 10x is 13x. So 13x minus 5 equals 34. And now if we add 5 to both sides, we're left with 13x equals 39, and then divide both sides by 13, we're left with x equals 3. So we've got our value for x. Now let's substitute that into our first equation. So we've got y is equal to 2 times x minus 1. Well, we know x is 3, so it's going to be 2 times 3 minus 1. So 2 times 3 is 6. 6 minus 1 is 5. So when x equals 3, y equals 5. Okay, let's look at question 3. So here we've got y equals 2x plus 1. So again, wherever we see a y in our second equation, we can just replace that with 2x plus 1. Or we could just do it the other way around. So we know that y equals 4x minus 3. So in the top equation, wherever we see a y, we can replace that with 4x minus 3. So let's do that. So the top equation, instead of writing y, I'm going to write 4x minus 3, and that equals 2x plus 1. 2x plus 1. So now we want to get all the x's on one side. So if I subtract 2x from both sides, I'm going to be left with 2x minus 3 equals 1. Now if I add 3 to both sides, I've now got 2x equals 4, and therefore x is equal to 2. X is equal to 2. And then again, we can substitute this back into our original equation. Let's use the second equation just because I haven't used the second equation yet. So our second equation, y is going to be equal to 4 times x minus 3. So 4 times 2 minus 3. So 4 times 2 is 8. 8 minus 3 is 5. So our solutions are x equals 2 and y equals 5. Okay, the last one, question 4. Now this is slightly different because we don't have a value for y. In all three of these equations we had y equals. Okay, but this one we don't. We have x plus y equals. So the first thing we're going to have to do is just rearrange this first equation to make y the subject. Okay, so if I just take this first equation and we want to make y the subject, so to get y on its own we're going to have to subtract x from both sides. So if we do that, we'll be left with y is equal to 6 minus x. Okay, I've just rearranged this formula to make y the subject. And now we've got y on its own, we can substitute this into our second equation. So just like before, wherever we see a y, we're just going to replace that with 6 minus x. So if I rewrite the second equation, we've got 5 times y, so 5 times 6 minus x, and then minus 3x equals 14. You just need to be really careful with all the negatives we've got here. So if we expand the brackets, 5 times 6 is 30. 5 times negative x is negative 5x. And then minus 3x equals 14. Now, if we add these two terms together, we're left with 30. And then minus 8x equals 14. And then let's just move up here to give ourselves a bit of room. So let's get the x's on the right hand side just so they're positive. So if I add 8x to both sides, I'm now left with 30 is equal to 8x plus 14. And now if we get rid of this 14 from both sides, we're left with 16 equals 8x. And then finally divide both sides by 8, we're left with 2 equals x, or x equals 2, whichever way around you would like to say it. So x equals 2, and now I don't really need to do any calculations. I can see that y is going to be 4 because 2 plus 4 equals 6. So x equals 2 and y equals 4. So how did you get on with those 4 questions? Now hopefully you can see that this method of solving simultaneous equations by substitution is a lot more efficient with these types of questions. So when you are solving simultaneous equations, the first thing I would do is I would look at the two equations and decide which method would be the most appropriate to solve those equations. In the next video, we're going to be looking at solving simultaneous equations using the elimination method. And I'm sure you are all itching to get going. Hopefully, I'll see you then. Take care.